Please briefly summarize your industry education, professional background, and current role at Nearmap.
I'm EVP and General Manager of our North American division. I've been with the company about 6 years and started off as VP of Marketing, then moved into the Executive Vice President of Product role, and then Head of Sales for North America. And now, since our vertical strategy has been taking hold, we've organized more clearly by vertical, so I'm managing the whole team. I have an undergraduate degree from Georgetown in Foreign Service, and I have a master's degree in demography, which is the science of populations, largely used in planning for various kinds of companies, telco, housing, commercial industries. And I spent roughly 35 years in the software business, largely in analytics and mapping, some customer relationship management, and now at Nearmap for the last 6 years.
How does Nearmap fit within the infrastructure industry? And how can aerial imagery in particular benefit the industry in ways that other tools can't?
So how does aerial imagery fit into the infrastructure industry? It is really a perfect fit. When you start thinking about infrastructure, we kind of think of the definition around it, and it's broad in our terms. It includes roads, highways, interchanges, bridges, tunnels, overpasses, heavy rail, light rail, airports, all sorts of other components: commercial housing, residential housing, culverts, water resources, parks, pavement, gantries. You get the idea. And in infrastructure, obviously, there's a process to perform site location, understand the site itself. There's your typically planning phase, there's the building phase, there's maintenance, and you could probably kind of carve it up into any number of other phases. But most of that work classically and historically has been done by people traveling on site. And on site, especially in a world where, we're having to deal with Corona and that is never really been the best way to do it, because you're requisitioning vehicles, you're gassing vehicles up, you're driving out there, and especially if you look at just site location. If you just focused on site location and you're trying to determine that you want to build in a certain area, you're looking at attributes about that area, such as presence of vegetation, impact on neighboring communities, access points, where could you build roads, height and elevation changes associated with the area. A lot of times people travel long distances to evaluate these areas, but with Nearmap, it's instantly accessible. So you can go online, quickly get access to it because we've got a broad coverage area. The imagery is up to date, so you're getting a current perspective. At the same time, you have the historical archive, so you can see how the area has changed. Try to kind of keep this brief. Take that idea and apply it to almost anything in infrastructure. As you're building, as you're maintaining, you're still going to want to see the infrastructure. You're going to want to see what needs to get built in addition to what's already there and what needs to be maintained. And it gets into subtle things like pavement markings, interchanges, all of that we kind of put into the big topic of infrastructure.
What's your opinion on the new infrastructure law and how will it help the industry?
Look, I think that there's a lot of infrastructure in North America that hasn't been maintained probably as well as it should. And, the country is so diverse that we've got quite, a network of infrastructure that needs to be maintained. So, my opinion is that with growth in the US economy, with growth in population, comes the need to maintain and expand the current infrastructure. And you see also at the same time, a lot of migration patterns where people are leaving one location, going to another location, leaving big cities, going to more rural cities. And it creates demands on the infrastructure in those new locations. So, I think that that on top of all sorts of technology like electric cars, the need for charging stations, all circles around how do you do this, right? How do you do it? And people have relied for a long time on, like I said, site location visits, but also lower resolution satellite imagery They've relied on field inspections, which are time consuming, and this could be optimized and made more efficient. So when you think of the infrastructure bill, this is really a perfect fit, in essence, to optimize how the money is spent associated with the infrastructure bill.
Can you describe one part of the law that isn't getting a lot of attention, but could be very important to the infrastructure industry?
I think that the use of technology to implement aspects of the law is not really an area that's getting attention. You've got a bit of a disconnect, right? We know we need the infrastructure that's part of the law, but now it becomes, well, how do you get the job done? And what access points do you have? And what technology do you have? And how is this going to become more efficient? And how do you optimize the process? Rather than throwing just money at the problem, how do you throw it at it in a way where you're optimizing the spend and therefore get more out of the entire process? I think there have been a couple of responses that have been put in the briefing document that you could probably rely on. That'll give you a little bit better answer to that, but that would be off the top of my head my response.
So what should our engineering audience be thinking about in terms of how this law will affect them, and how they can use it to their advantage?
Aerial imagery has come of age from the standpoint that there's a lot of different types of imagery that are valuable to engineers. So I'll keep this one simple. It started off years ago as just vertical top-down imagery, where you can just look at the building or the road from a completely vertical perspective, and you can see the roof, and obviously you can see the road and the markings and the landscape. It evolved into oblique imagery, which is imagery taken at a 45-degree angle, which anywhere between 15 and 45 degrees, which allows you to see the height of the buildings. And that later evolved into, let's call it the third generation, where you have 3D imagery. 3D imagery allows you to navigate through the landscape in a photorealistic manner, where you can navigate up and down the roads interactively on your computer, where you can look at the roof, but then look at the pavement and literally walk down a street or walk into an area and see what's there, including heights of trees, etc. So the industry has gone from vertical to oblique to 3D, and then the latest is automatic detection through machine learning and artificial intelligence of attributes that are significant in infrastructure builds, like construction sites, or the type of roof, or the roof material, or pavement markings. Remember, it used to be in years past, people would have to manually look at the imagery, and they have to go say, oh, I could see that looks like construction has started, or construction is about ready to end, or this pavement marking is light and needs to be repainted, or this interchange has got sort of, is in need of repair. It used to be people would have to manually inspect that. Now with AI, we can run algorithms against the entire library of imagery and automatically detect it. So for an engineer is going to want to use a technology like Nearmap to do that visual inspection across each one of those types of imagery, but do it from their desktop quickly. And in doing so, force multiply their efforts, where they're able to look at lots and lots of areas within a compressed period of time. That's key point number one. Key point number two is once engineers have identified areas that are of interest to them, they want to export that imagery, and they want to use it in a design product like a Bentley Systems product, or Autodesk's InfraWorks, or Esri's mapping technology. And most engineers are expertly trained in those technologies. So what we've done is we've given you the ability to look at Nearmap inside of our flagship product, which we call Map Browser, which is a SaaS-based product, accessible over the internet. As long as you have an internet connection, you can go and you can search and you can look in any area. But then, and here's the key, identify an area you want to export. And we make it easy to export the images, various kinds of images, in the formats that are compatible with the third-party products. Once the imagery is over there, they can get into much more detailed design and measurement and annotation that they need to do their job. So we think that's really, really important, and that's how we've architected it for engineers. The last point I'll make is we've introduced as part of the 3D set of imagery something called a digital surface model. A digital surface model means that within the image itself, you know the height of everything that's there. That includes low vegetation, medium, high vegetation, the height of the building, the height of the house, the height of each point on the house. In other words, the digital surface model has embedded inherently height. And that becomes important because now you're looking at things like, is there a hill? How fast will water run off? How much water could accumulate? Do I need to maintain the sewer system, build additional sewer systems? You can think of an endless number of applications that require the analysis of imagery vis-a-vis height to make decisions in the engineering world.
So could you provide perhaps one insider's tip or an expert's tip to our engineering audience on how they can use aerial imagery better to do their jobs, maybe something that they wouldn't have otherwise thought of?
It's going to streamline your workflow, meaning that if you use aerial imagery in its current form in Nearmap inside of the flagship product map browser, you're able to do a really sound visual inspection, including very detailed measurements. And you're going to be able to get a sense of the landscape and everything around it without really having to do anything else. It's literally username, password, login, search, you've got the location. The key tip there is that you can look back at how the location has changed, right? We've been at this now in the US since 2014. So we've got years of historical data. And so what you want to do before you start to do any real heavy design or engineering work is look at how the area has changed over time. Because we have consistent captures, meaning a spring capture and a fall capture, and a lot of times in many US cities, we do 3, we do summer, you really get a close look at the landscape and the infrastructure needs directly from map browser. And then the key tip related to that is now once you've identified your area that's of interest, export in the format that's consistent with your workflow and your tools so that you can easily bring data outside of Nearmap imagery and related data about the imagery and bring it into your tool of choice. So this is really a groundbreaking, revolutionary approach to the way engineers can operate. And then the last piece there is the collaboration. Because we're all looking at the same picture, we're logging into the same system. It doesn't make a difference where the engineers are. You could have one division in New York and one in California and one in Charlotte and one in Dallas, but everybody is consistently looking at the same picture with annotation capability. So you're in essence working collaboratively, and that just streamlines the entire workflow process as well.